arrows.
So can I start now? Okay. Yeah. I was saying, guys, you are welcome in our video today. We're looking at these quadrilaterals. Now, a quadrilateral is any four-sided figure. I repeat, a quadrilateral is what? Any four-sided figure. Ne? All together. Now, such figures include what? We have a parallelogram, we have a rhombus, we have a kite, we have a rectangle, and we have a square. They are all four-sided figures. Are we together? They are all what? Four-sided figures. Okay. Hope it's what I have here. So a quadrilateral, what's a quadrilateral here? A polygon is a two-dimensional figure with three or more sides, straight sides, okay? So a quadrilateral is a polygon with four straight sides. Are we together, guys? So we can have a rectangle. You see my rectangle here? We can have a square. Are we together? We can have a parallelogram. We can have a rhombus. And we have what? We have a kite, then the trapezium. Guys, do you see my quadrilaterals here, or you don't see them? Okay, can you see them? Can you see parallelogram here, guys? You see it, right? Can I proceed? You can see it properly. Yeah. Now, if you check parallelogram here, you see that that opposite sides are parallel. Ne? Are we together? Even here, they are also parallel. Ne? Now, look at the rectangle. The rectangle, also opposite sides, they are parallel and equal. Ne? What's the difference here? We have got 90 degrees, but we don't have what? 90 degrees in a parallelogram. I repeat, a parallelogram has got opposite sides, equal and parallel, which I think, guys, you can see. You can see that, right? And then a rectangle also has what? Opposite sides, which are equal and parallel. What's the difference here? We have got what? 90 degrees for the interior angles for the rectangle. Ne? So because of this, we say that a rectangle is a spatial parallelogram. Hello, are we together? Can I say that again? A rectangle is what? Is a spatial parallelogram. Also, only difference here that we have what? 90 degrees for the rectangle. Are we together now? And then, if you come to the rhombus, now the rhombus is a parallelogram with the equal sides. You see all the sides, they are still parallel, ne? The opposite sides, ne? And they are also equal, ne? But with the rhombus, all the sides are equal. All the sides are what? All the sides are equal. Do you hear me, guys? Meaning that if this is 7 centimeters, it's going to be 7 here, also 7 here, also 7 here. All the sides are equal, and the opposite sides, they are parallel. Are we together? Now, the difference from a rhombus with a square, a rectangle with equal sides, or you can say, yeah, that's a square. So a square is a spatial rectangle, okay? Note that a square may be defined as a rhombus with an interior angle of 90 degrees. So even a square has got all the opposite sides, all opposite sides parallel and equal, and all the sides equal. What's the difference here? We're saying that a square may be defined as a rhombus with an interior angle of what? Of 90 degrees. Are we together, guys? Anybody with a question? Hello? Kotso, are we together now? Adival, are we together? Okay, I asked you the difference between the rhombus and what? And the parallelogram. Ne? You see that the parallelogram, opposite sides, they are equal and parallel. Ne? What about with the rhombus? All the sides are equal. That's why we say that a rhombus is what? It is a parallelogram with equal sides. Can I proceed, guys, now? Are we together? What about a rectangle is a parallelogram with the interior angles of what? Of 90 degrees, which I think, guys, you can see here. Ne? Okay. What about a square? It is a rectangle with equal sides. Now, sometimes they can say that they can say answer whether it is true or false. Ne? They can say that a rectangle is a parallelogram. Is that true or false? What do you think, guys? Hello? If they say whether it is true or false, they say that a rectangle is a parallelogram. Are you gonna say it is false or true?
It's true.
That is true, ne? Because a rectangle is a parallelogram with what? With interior angles of 90 degrees. Are together? Now they can also say that a square is a rhombus. Are together? It's also correct, ne? Like we have seen that a square is what? Is a rhombus with what? 90 degrees of the interior angle. So it's also true, ne? Okay, let me talk about the kite now. So the kite has got adjacent sides equal one pair. So this pair equals this one here. Then this other one, the sides are also equal. Now the sides they're not equal like for the rhombus, ne? Like if this is 5 here, it's gonna be 5 at this side as well. So this could be 8 and the 8 here. You see, so only these two sides they are what? They are equal, okay, all together. And the more so are also with the kite. If I draw a line, ne? If I draw a line from the like this, if I draw a line, okay, like this one here, and I draw from I can have two diagonals, ne? I can have what? Two diagonals. I can have the longer diagonal and then the shorter one. Okay, this one here. Let me put it in a different color, maybe green. Okay. So you see that with the kite, I have got these two diagonals. Ne? Now tell me, guys, which of the two diagonals is longer? Is it the one in red or the one in green? Which one is longer? Hello? You see my kite here, ne? We have got diagonal one in red, another one in green. Which one is shorter? Which one is longer? Who can tell me here?
The red one is long.
Which one is longer?
And the green one. I mean the red one.
The red one is longer, ne? Now listen carefully. So with the kite, the longer diagonal always bisects the shorter diagonal. So this side here, this side, I beg your pardon here. Yeah, I'm saying something here. I'm saying that you see the longer diagonal, ne? It bisects the shorter diagonal. So this side equals to this side here. And we're gonna see more of this. That's how we know the rhombus, and they also meet at, I mean the kite, and they also meet at 90 degrees. Okay. What about a trapezium? Then with the trapezium, we only have one pair of what? Of opposite sides parallel. Eh? You see, only have what? One pair of opposite sides parallel. That's the difference between from other quadrilaterals. So anybody with a question, or we are together? Can I proceed, guys? Or somebody has a question? Ashi, did you have any question, or we can move on?
So we can move on.
Okay, thank you. Thank you. Let us go through these properties here. Just remind us properly. Can I zoom, or the size is fine? Must I make them bigger? Yeah, I think it's fine now, ne? Okay. Now I'm gonna read for you here. This one is it is what? It is a parallelogram. Okay. The diagonals of a parallelogram bisect each other. Okay. Then the opposite angles of a parallelogram are equal. The interior angles add up to 360 degrees, and also the opposite sides of parallelogram are parallel and equal. I repeat, for the parallelogram, the diagonals bisect each other altogether. What do you mean in this case? That if this is 4, it's going to be 4 here as well. Ne? If this is 3, it's going to be 3 here. Ne? Because to bisect means you're dividing into 2 equal sides. Ne? So these are the diagonals, ne? The BD and AC. They bisect each other. And then the opposite angles of a parallelogram are equal. Ne? If this one is, let's say, 88 degrees, it's going to be 88 degrees here. All together. If this is, let's say, 120, it's going to be 120 here. All together. So the opposite angles are what? They're equal for the parallelogram. Can I proceed? And then you're saying that the interior angles add up to what? 360 degrees. And also note that the opposite sides of the parallelogram are what? They are parallel and equal. Let me go now to the rhombus. This is now a rhombus here. This was a parallelogram here. This is now a rhombus, okay? Now the diagonal of the rhombus bisect each other at right angles. This they meet at 90 degrees here. And then the diagonals bisect the vertex angles. So diagonals in this case for the rhombus, they bisect the vertex angles. Ne? What do you mean here? That if this one is, let's say, if this is 44, okay, it's going to be 44 degrees this side because diagonals bisect the what? The vertex angles. Are we together, guys? And then also the opposite angles of the rhombus are equal. The interior angles add up to what? 360 degrees. And then the opposite sides of a rhombus are parallel and equal. And all sides are equal. Are we together? Okay, let us proceed here. Next. This is now a rectangle here. This is a rectangle here. Now with the rectangle, it's a rectangle here. With the rectangle, what do we say here? The diagonals of a rectangle bisect each other and are equal in length. Then the interior angles of a rectangle are equal to 90 degrees. And the interior angles add up to 360 degrees. All together. Then the opposite sides of a rectangle are parallel and equal. What about a square? Then for the square, the diagonals of a square bisect each other at right angles. And they are equal in length. The diagonals bisect the vertex angles as well. The interior angles of a square are what? Are equal to 90 degrees. And the interior angles add up to 360 degrees. Then the opposite sides of a square are parallel and all sides are equal. I think we are together, ne? Okay. And then in here, we talk about this is now a trapezium here. The diagonals of the trapezium intersect but don't bisect each other. They lie between parallel lines and therefore the right angles are equal. The interior angles add up to 360 degrees, and then also one pair of opposite sides are parallel. Okay, and then let's continue here to the kite. This one is a kite here. The diagonals are perpendicular, and one diagonal bisects the other one of the diagonals. I repeat, this is a kite here. Ne? The diagonals are what? They are perpendicular, meaning they meet at 90 degrees, ne? Which I think you can see it here. Ne? At 90 degrees here, and one diagonal bisects the other. Okay, then one of the diagonals bisects the vertex angles. So this one here is bisecting the vertex angles. Okay, it's bisecting what? The vertex angles. Okay, we're saying here that one pair of opposite angles are equal, and then the interior angles add up to 360 degrees, and then the two pairs of adjacent sides are equal. That is it about the quadrilaterals, guys. That's about the quadrilaterals there. And now we have got theorems here, how to prove a parallelogram. Okay, but I'm going to go to the one which summarizes everything here, because I sent you this on the group chat. Ne? You can always check through. Okay, so we can do our homework. Ne? How together, guys? I'm saying that I sent you the theorems on the group chat. Ne? So I want us to see what is most important here, to know how to prove what? A parallelogram. Ne? Okay, it is this one here. Yeah, where we have the note here. All right, let me just decrease a little bit, it's too big. I think now it is clear. Ne? Hello? Guys, do you hear me? Are we together? Now,
Yes.
here the question, here, note something here that the question is gonna say, prove that this one is a parallelogram, ne? So we can prove any of the following, ne? We're saying that in order to prove that a quadrilateral is a parallelogram, okay, it's a parallelogram, you will need to prove at least one of the following, ne? You can prove one of the following, ne? This is our parallelogram, I mean our quadrilateral A, B, C, D. Now, if we can show that our AD, you see this AD is what? Parallel to BC, and also AB parallel to DC, then we say it's a parallelogram. So this is number one, which you can use. Okay. Now, as you're gonna see now in our proofs down there, if we can show that any opposite sides, any two opposite sides, they are what? They are parallel, then that's a parallelogram, and it is sufficient. And it is what? Sufficient. Now, when I say sufficient, I mean it is enough. Ne? If they say, prove that this figure is a parallelogram, if you can show that opposite sides are parallel, ne? Then it is what? It's a parallelogram. Hello, do you hear me? Can I proceed? Adiva, can I proceed?
Yes, sir.
Okay, now look here. Another way to prove, we can say, if we show that you see our AD, if AD equals to BC altogether, and then AB equals to DC, look here, if AD equals to BC altogether, and then AB equals to DC, and then opposite sides are equal. So if we can show that opposite sides are equal, then it is what? It's a parallelogram. That's another way of proving that. That's number two. Are we together? Then another one, if our AE, check here, if AE equals to EC, you see my AE there? If AE equals to EC, and also BE equals to what? To ED, it is also a parallelogram. That's number three. The reason which we give, we say that because diagonals bisect each other. We say what? Diagonals bisect each other. Okay. Diagonals bisect each other. That's why it's a parallelogram. Are we together, guys? Can I proceed? Also, if you can show that our angle A, okay, is equal to angle C, are we together? And also angle B is equal to angle D. It's also what? It also shows a parallelogram. What's going to be our reason here? Opposite angles are equal. Okay. Opposite what? Opposite angles are equal. That's number four. Okay. And then also if we can show that our AB, you see our AB is, if AB is parallel to DC, okay, parallel to DC, and the AB equals to DC, okay, and AB equals to what? Equals to DC, it is also a parallelogram. The reason being what? One pair of opposite sides equal and parallel. That's number five. I repeat, guys, I'm saying that if you can show one pair of opposite sides equal and parallel, then it's a parallelogram. That is to say, if you consider that our AB, for example, AB is parallel to what? To DC, and also AB equals to DC, then that's a parallelogram. Ne? All together, guys. However, we can also show that AD, this AD is parallel to what? Parallel to BC altogether, if they are parallel, AB and BC, and also AD equals to BC. That's the same reason as this one here. Ne? So you can show that something is a parallelogram if you can prove any of these five reasons here. Are we together now, guys? Can I go to the questions now? Hope we are together, ne? Lulama, are we together? Are we together, Lufuno? Hello.
Yes.
Okay, let's go to questions now. Ne? Let's go to your questions now, guys, so we can answer them now. Okay, they're just here. They're just here. This one I think was from Ashley here. Now I'm going to use what I just told you now to prove this. Ne? Okay. So the question says here that KLMN, you see this is KLMN, is a quadrilateral with the angle K equals to angle M. They're saying angle K equals to angle M and the angle L equals to angle N. They say prove that angle K plus L equals to what? 180 degrees. Are we together, guys? Now, as you can see from this diagram here, they told me that the opposite angles are equal. Ne? Did you see that, guys? They said what? They said Km. Okay, I'm doing question 4 here. They said Km, angle K equals to what? Angle M. Ne? Are we together? And the angle L equals to which angle? Angle N. Are we together? So, what does this one show us? And this one is given to us. Ne? What does it show us? That our figure, which is K, KL, M, KLMN is what? Is a parallelogram. Who can give us a reason here? Why do we say so? Why do we say it's a parallelogram here? Because of what? Because opposite angles, they are equal. You see this angle N equals what? Angle L. Are together? Also angle K equals to what? Angle M. So because of that, then it must be a parallelogram. So this was to answer part B. Actually, this is part B of the solution. Now part A, I'm coming to part A now. They say prove that K plus L equals to 180. So I'm gonna say that my K, I'm gonna say that my Kn, okay, I'm gonna say Kn is parallel to what now? To ML. Why? Because these are opposite what? Opposite sides of a parallelogram. These are opposite sides of what? Of a parallelogram, okay? Opposite sides of a parallelogram, okay? So now, because they are parallel, then it means what? It means that my angle K plus what? Plus my angle L must be 180 degrees because of what? The angles, the co-interior angles between parallel lines. Because of what? Co-interior angles between what? Between parallel lines. That is it there. Are we together actually now? That was part A. That's part A and B. Actually, are we together now?
Yes, sir.
That's what you wanted, okay? I'm sending it on the group chat, guys. You can check it there if you want to check it for more time, okay? It's there right now. The group chat, you can check it. Let us proceed. Next question here. Now they said question 5 that ABCD, they're saying the parallelogram with diagonals AC and the BD intersecting at O. Prove that triangle AOB is congruent to triangle COD. Let me clean up this part now, guys. I can have enough space here. I'm cleaning up this now. Okay, just prove whatever I wanted there. They're saying here that this is a parallelogram. This is what? A parallelogram. You can see the guys, they're saying that ABCD is what? A parallelogram with the diagonals SC and BD intersecting at O. All together? Then they say prove that triangle AOB is congruent triangle what? COD. Okay. Let me highlight those triangles they're talking about here. They're talking about triangle AOD. Now this is our AOD here. This is our AOD here. This one I'm putting in green here. This is our AOD, triangle AOD. This one here. Okay. Triangle AOD. I'm putting it for you in green here, so you can see it properly. Triangle AOD. Okay. Triangle AOD. Triangle AOD. triangle AOD here, AOD, and oh no, it doesn't work out properly. Let me get another one here. Okay. Now this triangle AOD, as you can see, it is opposite to triangle COD. Ne? I'm now using a red color for COD. COD, I'm using a red color, guys. COD. This is COD. Okay. Now, what are the conditions for congruency? Anybody who remembers? What did we talk about last time? Do you remember any of the conditions for congruency? We talked about what? Any conditions for the congruency? Okay, now if you look at my triangles here, guys, do you see any sides or angles which are equal? If I say this is O1 and then O2, do you see any sides equal or any angles equal here? We're proving that's question 5A, okay? 5A. You're going to set from triangles, okay? We said from triangles A or B, from triangles A or B, and also triangle COD. Do you see any equal sides, guys, here, or any equal angles? Talk to me. O1 equals to O2. Do you see that, guys? O1 equals to what? Equals to O2. Can you give us a reason here? Why do we say O1 equals to O2?
Vertical opposite angle.
Thank you so much. Vertically opposite angles, ne? Vertically opposite angles. Vertically opposite angles. So do you see any sides equal? Talk to me, somebody, please.
Is it correct if I say AB is equals to DC?
And the reason being what?
They are parallel.
No, Adival. That's not the correct reason, but your statement is correct. AB equals to CD. Who can give us a reason here?
Is it because it's given?
No, we say because these are opposite sides of a parallelogram. We don't say given. What do we say? We say opposite what? Opposite sides of what? A parallelogram. We say that they must be equal, isn't it? Opposite sides of a parallelogram. Ne? I forgot to write it properly here. Opposite sides of a parallelogram. Okay? So these are sides. Ne? I'm gonna put S in brackets here. What else is equal? You can tell us now, guys. Any other equal side or angle? Who can tell us? Come on. Any other equal side or angle? Hello.
Okay, will it still be correct if I say angle B is equals to angle D?
Come again. Angle D.
Angle B.
B. You mean
angle B, sir.
You mean B1?
Yes, sorry, sir. B1 is equals to angle D1.
Reason being what?
Alternate angles.
That is correct. So our angle B1, okay? Our angle B1 equals to angle D1. Reason being what? Alternate angles. Alternate angles, ne? That's an angle, ne? So I think you can see now, ne? Therefore, the triangles are congruent. That's A or B is what? Congruent to triangle C. Who can give us a reason now? Why do you say they're congruent? Because of what? Because of angle, side. Yes, come again.
I was about to say the same thing.
Oh, yeah, thank you. Because of what? Angle, and then side. Ne? As you can see, you have got this angle here, this angle, then this side here. Ne? That's why triangles are congruent. Hello, are we together now? Can I go to part B? They said prove that diagonals bisect one another. Okay, the diagonals bisect one another here. Now, what can we do here to prove that? Now, if the triangles are congruent, guys, ne? Like we're saying here, triangle they're saying triangle A O B, is congruent to triangle what? COD. COD. Reason, we can say it is proven. We just proved it now, all together. But now what do we observe from here? It means that our AO, this side here, guys, our side AO, all together, equals to side what? Who can tell me now? Equals to what from this side? Who can tell us? Our side AO equals which side?
CO, sir.
Yeah, side CO. So if the AO equals to side CO, what does that mean to us? That this is a bisector.
Bisect.
This is a bisector here. Also, this other side, look at my OB. If you look at our side OB now, this OB equals which side? That this side, guys. Who can tell us here? OB equals to what?
O,
Equals to
OD, sir.
OD. Thank you, Adival. So because of that, also this side equals this side here. So as you can see, this therefore these are bisectors. We say diagonals bisect one another. Reason being what here? We say because of congruent triangles. Because of what? Congruent triangles. Are we together, guys? Let's write it here. You start, actually, do you hear me? You start from here, ne? Don't answer part B. Start from here, then here you conclude by writing this statement here. You say because of what? Congruent triangles. Anybody with a question, or we are together? Anybody with a question, please ask, don't keep quiet. Anybody with a question, I'm sending it on the group chat as well. Anybody with a question, ask, please don't keep quiet. So we can proceed. Actually, are we together now?
Yes, sir.
Yeah, so that was from Tom Nude. Also this one here as well is also from Tom Nude. Okay. Okay, there they said ABC the parallelogram here. You see ABC is what parallelogram here? Prove that triangle ABD is what? Congruent triangle CDB. CDB. Now here because of our time, okay, let's do it now. We are going to say from triangles ABD and triangles CDB. So do you see any equal sides or angles, guys? Tell me, please. I'm doing this question now, question 2A here. We say that from triangles, okay, we say that from we're doing question 2A, we say from triangles, okay, from triangles ABD, okay, ABD, and the triangle what? And triangle CDB. So, do you see any equal sides here, all the angles? Please talk to me now. Somebody? From triangle ABD,
sir,
yes, please. Talk, tell us also, yes.
Sir, is B1 is equals to D2.
The reason being what?
Alternate angles.
That is correct. Thank you. B1 equals to D2. Reason being what? Alternate angles, okay. That's an angle, ne? And then what?
Angle AD is equals to angle BC.
Come again.
AD is equals to BC.
AB equals to?
BC.
No. You say the AB equals to BC? No. Can you say it again properly? Who can correct her, please? Anybody there? What do you think, Lufuno? What can you say here? These are now slides. You say what? Come on.
You're saying that AD is equal to BC.
AD equals to BC. Reason being what?
Parallel angles. AD is parallel to BC.
Now let me help you here. Guys, when you say that our AD, okay, our AD equals to what, guys? You see this AD, ne? Equals to this BC, right? AD equals to what? Equals to BC. Now, the reason here we should say it's because of what? Opposite sides of a parallelogram. Do you hear me now, guys? They said it's a parallelogram already, and we know that both sides they are equal and parallel, né? So that's why they are equal here. We say they are because of what? Opposite of parallelogram. Am I clear now? Are we together, guys? What else do you see here? Come on, what else do you see here? Any other equisidal angle? Who can help us here now? One more we need here to prove this. Come on.
B1 equals to D2.
But we finished that, Ashir. It is here. Another one. Another one.
AB equals to DC.
Come again.
AB equals to DC.
DB equals to DC. Is that what you said?
No, AB equals to DC.
Equals to DC. Thank you, Ashley. Our AB equals to DC. Who can give us a reason now? What do we say here now? Who can tell us?
Opposite angles of a parallelogram.
Opposite sides. Opposite what? Opposite. These are sides, right? Right, Koso? Opposite sides of what? Of a parallelogram. Lufuna, are we together? So, what do I put it? It's a side here, ne? So, guys, you can see it's now gonna be it's now congruent, ne? Who can give us a reason here? Why do you say the triangles are congruent? Because of what? Talk to me. Why are the triangles congruent now? Because of what?
Angle, side.
Yes, so you can say because of side, angle, side. Are you together, ne? But you also correct that way. You can say angle, side, but we better say what? Side, angle, side. Okay, now from this, now I want to show that our angle A equals to angle C. What do you do in that case, guys? Who can help us? That our angle A equals to angle C. What do we do in that case? Who can help us in this case? What do we do?
Opposite. Oh, sorry.
Yeah, just say it out, please. Come on. Any
I
idea?
was about to
Yes,
say.
say it.
I was about to say opposite sides of a parallelogram, say, because A is opposite to angle C.
Oh, you mean opposite angles of a parallelogram. Up these are angles, ne? These are what? These are angles, ne? Isn't it?
Yes, sir.
Yeah, you are correct. We say that angle A equals to angle C because of what? Opposite angles of parallelogram. You can say because of what? Opposite angles of what? A parallelogram. That's correct, ne? But however, you can also say it like this, ne? Because the two triangles are congruent, ne? You can say because of the congruent triangle, it's also fine. I repeat, you see these two triangles, they are congruent, ne? Meaning that angle A, this angle A, equals to angle C because the triangles are congruent. That's another reason. Okay, do you get it now? What about here, part C, where they say prove that angle ABC, angle ABC is equal to angle ADC. Now here, because you don't have the two triangles, ne? Now here you better say opposite angles of a parallelogram. That is the best answer now here. Guys, do you agree with me? Are we together? That our angle ABC, are together, is equal to angle what? ADC. Reason being what? Being opposite angles of a parallelogram. Hope we are together, guys, now, ne? So you see here the best answer, part B, was to use the triangles which are congruent, ne? Then on part C, use now opposite angles of parallelogram. Are we together? You can check on the group chat, guys. I'm sending it now. You can check it there, and then you can proceed to write it down. Okay. Anybody with a question, or we can proceed? Should we continue, or somebody has a question? Anybody with a question, please ask, or we can proceed. Okay, question 3. They said that PQRS is a quadrilateral. I'm cleaning off this, guys. If you want to check it, you can check on the group chat. Don't worry about it. I put it there already. They're saying that PQRS is a quadrilateral with the PQ, with the side PQ equal to SR, all together. And then they say that also PS equals to what? To QR. Then prove that triangle PQR is what? Is congruent to triangle RSP. Okay. I repeat, they're saying that PQRS is a quadrilateral altogether. They say that with the PQ, this PQ equal to SR, and then PS equals to QR, prove that triangle PQR is what? Is congruent to triangle RSP. Okay. Any ideas here? What do we do here? Any ideas here? What can we do here? Any ideas here? Yes, please.
I was about to say, angle PQ is equals to SR. It's given.
Now look here. Be careful. The PQ is not an angle at the vowel. PQ is what? Is a side, isn't it?
Yes, sir.
So you have to be careful. But otherwise you are correct. Okay. Now we're doing question 3A here. We're going to say that we say that from, okay, we say from triangle PQR altogether, PQR and what? And triangle RSP. Now say it correctly. Can you say it again now?
PQ is equals to SR. It's given.
PQ equals to SR. Okay. Or you can say RS. Reason being it is given. What else do you see, guys? Talk to me. What else do you see here? Apart from that?
SP is equals to RQ.
Yes, also SP equals to RQ. Reason being what? Also given, right? What else do we see here? What else do we see here? Who can tell us now? Come on, somebody. Hello. Yes.
PR
Yes.
is equals to PR. It's a sharing angle.
That's common, Is that common?
Common.
Yes. So PR equals to PR, Reason being it is common. We see it is common, and it is a side. Okay. So now, therefore, a triangle PQR, okay, is congruent to triangle what? RSP. Who can give us a reason here? What's our reason going to be here now?
Side.
Yes, side. Okay, that is it, guys. And then lastly, prove that PQ dot RS and PS dot QR. What do they mean by the dot now? They say the PQ dot PQ dot RS and the PS dot QR. What are they meaning here, guys, now? I think they want to show that they are equal, that PQ equals to what? Equals to RS. All together? PQ equals to what? RS. And the PS equals to Q. But that's what they gave us here. Yeah, now it's confusing. I don't know what they want here actually. The two dots. What do the two dots mean? Actually, this is from Tom Note. Tell us now. What did you tell you about the two dots? You said what?
You say you're right. There is the saying PQ equals to RS and PS is equal to QR. I think they want us to give the reason why they're equal.
But they gave them to us here, most. You see that is here in the question. So why do they ask us what they gave us already? Let us keep it now. Guys, are we together?
Yes, I'll ask.
We'll ask you here tomorrow, ne? Okay. Now they think that RQRS is a parallelogram. Okay. Now look at them again. They're saying RQ and then RS is a parallelogram. Yeah, there now we understand. Who can give us a reason here? Because opposite sides they are what? Opposite sides are equal. Because the two pairs of opposite sides is equal. Because what? Because the two pairs of what? Of opposite sides are equal. That's why it's a parallelogram. All together? That's why it is what? A parallelogram, ne? Because of what? The two, you see this pair is equal to each other, and also this PS equals to QS, ne? So because of that means that this must be what? Parallelogram here. Alright guys, that is it for today. We're gonna finish up this on our next period, ne? Our time has expired now. Thank you so much for watching. Catch you in our next video. We're gonna proceed from here in our physics, okay? Before we do physics, okay? Bye bye. See you soon. Bye.
Bye, sir.
Bye.